Introduction to Rational Functions and Their Graphs, Section 2.6. We're going to start out today just simply by finding the domain of rational functions. We're going to use arrow notation to identify what the function is approaching, identify vertical asymptotes, and we're going to stop right there for this video. So to jump into this, we first start out with find the domain of each. Now, in order to find the domain, remember we had two things we're looking for when we're looking at domain. Number one, x's in the denominator, and number two, x's under the radical. All right, so this should be a review. We know that for number one, or for A, I'm sorry, x cannot equal 5, therefore our domain is going to be from negative infinity to 5, union 5 to infinity. All right, now that would be all fine and good if we had factored. Now this is still going to be true, but keep in mind that this up here becomes x minus 5, x plus 5, which means that and that cancel, right? So this is actually y equals x plus 5. Now that doesn't actually change the domain because we still have to consider this before we simplify. Now what this means is that instead of there being an asymptote, a vertical asymptote, there's a hole in the graph at x equals 5. Okay, in other words, your graph is going to continue, it's going to jump over a hole, and it's something like that. Okay, whatever that is. Now we know that y equals x plus 5 is a linear equation, and so there's a hole in the graph instead of an asymptote. And I guess you could theoretically consider it still to be an asymptote. Okay. Part B. We're going to rewrite this as x over x minus 5, x plus 5, and we know then that x cannot equal plus or minus 5. There's nothing that cancels, nothing that simplifies. So our domain now is negative infinity to negative 5, union, negative 5 to 5, union, and 5 to infinity. Okay, now this one does create a situation where there is a asymptote. Okay, and I'm going to suggest you take a minute and plug this into Desmos and see how this this function differs from A. You guys do need to do some investigating. These are similar, or they look similar, but they're not the same. Okay, and then part C, again, is I think pretty interesting in the sense that this will give us imaginary solutions. So this actually doesn't cross or doesn't have any asymptotes because we know that if you solve for x squared plus 25 equals 0, you got imaginary solutions. So this leaves us with a domain that is from negative infinity to infinity, even though there's an x in the denominator. All right, the line x equals a is a vertical asymptote. This is what they're saying is x equals a. Is a vertical asymptote showing that the graph, or where the graph will not cross. The graphs will not cross the vertical asymptotes. So in this case, what I want you to notice is that the function itself is approaching the graph, right, as x gets smaller, right, or as x is approaching from the positive side. This is considered the positive side of this asymptote right here. Okay, x is going to approach infinity. As x approaches the asymptote here from the negative side, the function approaches infinity. Over here, when it approaches from the positive side, the function goes to negative infinity. And over here, when it approaches from the negative side, it also goes to negative infinity. Okay, now, this is one where you kind of got to get a feel for that a little bit as we go. But we're looking at the function as it approaches a number. Okay? If you go back to this, remember as x approached here, approached that hole, it won't cross that. But you know, what is the y value as it approaches? Well, the y value is going to approach, you know, whatever it is on the graph. All right. So locating the vertical asymptotes. If the function p of x over q of x is a rational function in which p of x and q of x have no common factors, and a is a 0 of q of x, the denominator, then the x equals a is a vertical asymptote. Okay, remember we had a situation where we had x over x minus 5, x plus 5. That gave us two vertical asymptotes at x equals 5 and x equals negative 5. We also had a situation where it canceled, so that's why they said where they have no common factors, where they can't cancel. So when they have a hole in the graph, we don't usually consider that to be an asymptote, if that makes any sense. All right, find the vertical asymptotes. Well, this factors into x minus 1, x plus 1. So my vertical asymptotes are at x equals 1 and x equals negative 1. For g of x, this factors into x minus 1, x plus 1, where the x minus 1s will cancel. Okay, so we're going to have a hole at x equals 1. We're going to have an asymptote at x equals negative 1. Okay, and they're different. Okay, the function will approach an asymptote. The function is going to jump over a hole. And then C, there are no asymptotes. Because this is not going to factor into real numbers. All right, that's enough for today. Good luck.